Okay, next we have Anita, and she's got a machine that does the following inputs and outputs. I'll make that into a table so it's easier to see. There we go, and that's all we have. It says write an equation for her function machine. I don't know if you learned this in middle school or a previous algebra course or something, but if you're seeing that, one way to do this is if you're seeing a constant step up here by a certain amount, and then there's a constant step up here by a certain amount, the thing might be probably linear. Here we went from 3 to 4, this went up by 2, and if we step backwards from the 3 down to -3, we'll also see that if we keep stepping down by 2, we do actually get to -5. So this thing turns out to be linear. The constant difference here is 2, so the slope is, that's a y, the slope is 2. This is y equals 2x, and if I substitute a point in there, I can figure out that the y-intercept turns out to be 1. This skill right here is not a very popular skill that you're going to have to do in this unit, but just in case you'd seen that before, that's what that is. But let's write that as f of x. Okay, so that's the equation for her function machine, and you could check that by putting all these numbers in and seeing if that works. And then let's see if it's possible, and this actually looks like a little meat grinder kind of machine. If you could turn that backwards and put in, figure out, if you knew what was coming out here, you could figure out what came in. Let's see if we can reverse that. So what changes, like kind of what does this backwards thing that would change a 7 into a 3, or a, whoops, let me fix that. And you might ask yourself, well, yeah, this also kind of looks linear. What would happen if these were the inputs and these were the outputs? It turns out that this is also going to be linear. Of course, you might guess that because this is linear. As I'm stepping up 1 here, I'm stepping up half on this side, so the slope is half. It turns out, let me just write it for you. F of x is x minus 1 divided by 2. You could check that if you try all the stuff in here. Lo and behold, that works. Now, how did we get that? This is what you do algebraically. Now, this is easy to confuse with the earlier instructions about verifying whether or not two things given are inverses. That skill is, here's the two things, find their inverse. This is, or sorry, verify if they're inverses. This is different. You only get one equation, and it says find the inverse of this on your own. Okay, so we want to switch inputs and outputs essentially. So what happens here, and how I kind of did that other one, if I did that too fast, was follow this protocol. So switch the x and y. Rewrite this as x equals for y plus 8, because that switches inputs and outputs essentially. And then, of course, we can't write this as an x equals equation. We have to write this as a y equals equation. So we just solve this for y equals, I'll put it on this side, that's also okay. And we have x minus 8 divided by 4. You can write it like that. You can write this as x over 4 divided by 2. That's fine. Let me do another one. If y equals half x minus 4, the inverse is, this represents the inverse, but I got to finish this. X, and these linear ones all kind of go the same. And so y is 2 times x plus 4. And this is fine. It's just write an equation. It doesn't have to be perfect. Oops, that's a 4. It doesn't have to be perfectly like the best, most proper way to write y equals x plus 3. That is a 4, by the way. If y equals 2x minus 5 over 6, then the inverse is going to be this when I solve it. Oh, I maybe should have combined that 2 and that 6 earlier. I guess I'm doing that here. 3x equals y minus 5. Sorry for the handwriting. So y equals 3x plus 5. Okay. By the way, there's a better version of this in terms of handwriting on the website, on the Schoology, and it has things downloaded, and it looks a little bit nicer. It looks like this because someone did this not on a video, but they did it as an actual iPad document and not live. That's a lot nicer. Anyway, here's a little reminder of how everything works. It's got all the information we've talked about so far about symmetry and about reflections, about how to find stuff. Yeah, so I can let you read that, or you can pause right now. The last page of this has this thing called extension, which really is kind of an important concept. It's not really, shouldn't really thought of as extra. What about, there are certain functions that when you try to inverse them, a certain kind of common and weird thing happens. Take any number, that's a 4, square it, and take the square root. Well, that's all great until, what if we started with a negative number, right? Take a negative number, square it, great, and take the square root. Okay, all of a sudden we don't get back to where we started from, but sometimes we do, so it's kind of a sometimes inverse, so be worried about that. This is great if everything's positive, of course, right? So this is going to be, oh, this is the square root, yeah. and take this and you square it. So if we're switching x and y, everybody's happy. But you notice there's some kind of funky stuff going on. So let's graph the things. Well, if we're graphing in this window, one of them kind of looks like, well, that's not great. One of them looks like they're gonna both go through 1, 1, 2, 4. It's gonna be something like this, and the other one's gonna go through 1, 1, also kind of like that, right? This is the square root, and this is the squaring. That's all great if we're in quadrant 1, but if we go over here into quadrant 2, then things start to get a little bit weird. It's still got the nice mirror line over y equals x, but yeah, it was supposed to have the shape you're expecting. This should look like parabolas. But if we start with this whole thing and try to invert it, notice here we're starting with the square root of x. If we start with x squared and try to invert it, find the inverse, things are a little bit weird. If we take all of these points, reverse them, reflect them over the axis, we're going to get something that looks like this. And then it's also going to come in here like this. I can do this funny because I'm on this software. Anyway, we get that, and that thing's not a function. We could have kind of predicted that wasn't a function because the original was not 1-to-1. So when we want to make a function that's, an inverse of something that's going to turn out to a function, we have to kind of cut up the domain of that a little bit. So why do we not consider half of the parabola as being an inverse? Because we wouldn't have this 1-to-1 problem. Sometimes you might see problems that say, restrict the domain of f of x so that it is invertible. So you might say, if f of x is x squared, that's only going to be an inverse if we're only considering the values where x is greater than 1. So you might see these problems, or in another class maybe, where they actually talk about restricted domain. So you'd say this is invertible as long as x is part of the set where, I should probably do this interval notation, where we're talking about like x is from 0 to infinity only. Then your graph just looks like that, and you can go ahead and invert that. Okay, and then just before you start the worksheet, just one last note about this, because people always get this wrong on assessments and then they get mad. So, so to avoid future fighting, there's two kinds of questions where they ask about inverses, really. And this is the one where you switch x and y and you go to town, right? Find an equation for the inverse, switch x and y and find it. This question is specifically asking you to verify algebraically that the two things given are inverses. So what you're not supposed to do here is switch x and y and try to find it and see if it equals that thing. That's not what they're asking you to do here. What they want you to do is use composition, try the f of g of x, and see is f, I should probably write this down. Here what you're supposed to do is f of g of x, and you work this out, and you try to see, does that thing equal x? And then, of course, if it does, then you have more work. You have to see if g of f of x also equals eventually x. And if it does, then you've got yourself inverses. Do not, let's put this here so it's in writing. If you're watching this muted, don't go, oh, x equals 3y plus 6. Try to solve for y equals, and see if it equals g of x. This is not what this question is asking. That's what you do. That's what you do when you're doing these questions, when there's only one to do. Okay, that's it. I don't want to make this video longer than it needs to be. Thank you for watching.